I remove now the bad MOSFET, and this is the good one. But pay attention. Do you see this mark? This white mark means the first pin. This is the input power for the power to the motherboard. Here we have the cable. Here, as you can see, this is the IC. This is the charge IC, as you can see. Here we have the coils, inductors. As you can see, we have PL. This is inductors. The 19 volt should pass through these inductors and then should pass through this MOSFET and then this MOSFET and then goes to this resistor. This is current sense resistor. And then from here, the 20 volt will be distributed to the whole motherboard. As you can see, here we have one circuit. As you can see, here we have another circuit. As you can see, here this is another circuit. We have here another circuit. Here also we have another circuit, as you can see. So here also we have another circuit here, as you can see. We have a power management IC, as you can see. We have MOSFETs. So always when you find a group of capacitors with inductor means a circuit. Okay, so here, as you can see, we have capacitor, we have inductor, we have MOSFETs, and this is IC. Okay, here also we have a group of capacitors here, we have inductors here, we have IC. So this circuit is for the processor. Always the circuit of the processor contain many capacitors. Okay, so this is the circuit for the processor, and this is the CPU management IC. Okay, here also we have another circuit. Okay, and here also we have another circuit, as you can see. Okay, we have inductor, capacitor, and here we have the IC. So this seems to be the 3 volt, 5 volt system power, because we have two inductors, one inductor for 5 volt and another for 3 volt. Okay, so before going and diagnosing the motherboard, let's first check something. So as you can see, always when you get a failed motherboard, okay, a dead motherboard or a motherboard with no data or no power or no light, first thing to do is a visual inspection. Okay, so always you should make a visual inspection. But first, let's remove this, the fan. Okay, let's remove first this, the fan and the heatsink, in order to be free in the motherboard. So to remove this, we can just remove these screws, as you can see. The screws for the fan, as you can see. So we will remove this fan in order to be free in the motherboard, in order to see all components. Okay, so here we have the fan now is removed, as you can see. So what about the heatsink? As you can see also, this is bad for motherboards. This can cause a graphical failure. Okay, so this should be cleaned in order to avoid to damage the graphic cards. Okay, this is bad for the motherboard. Now, anyway, for the heatsink, no problem. Now we see all the components, but let me first remove this dirt here. So now, as you can see, I have cleaned this heatsink. As you can see, now is clean. You can even remove the heatsink, okay, and wash it using water. No problem. You can even remove it and wash it using water. But to remove the heatsink, you should pay attention to the screw number. As you can see here, we have here 1, 2, 3, 4. We have here 5 and 6. You should not open any screw randomly. No, you should always respect this order. first you should remove this screw. We have here 1, then 2, then 3, then 4, then 5, then 6. In every motherboard you will find the same working principle. You can find just 4 screws or even 6 or more. Why? Because, for example, if you loosen the number 3, then number 6, then you can damage the heatsink, or even you can damage the processor or the GMC hedge. Okay, so always try and respect the order of screws. Okay, so now as you can see here, this is the heatsink, as you can see. Okay, under this heatsink, as you can see here, we have under this the processor, and under this part, as you can see, this is the GMC hedge, and this is the IC hedge. Okay, so the processor, the GMC hedge or the NOT bridge, and here, as you can see, we have the IC hedge. Let's unscrew these screws in order to check these chips. Okay, so let's begin with the first screw. Here we have 1, so let's check. Here we have 1, so we have here 2, here we have 3, okay, number 3, 4, so this is 5, and 6. Okay, now we can remove the heatsink easily. As you can see, we can remove the heatsink easily. Okay, as you can see, this is the heatsink. Okay, so as you can see here, this is the processor. As you can see, this is the processor. Okay, here we have the GMC hedge. Okay, so this is the GMC hedge, as you can see. Okay, and here this is the sewed bridge. Okay, this is the sewed bridge. Okay, so the processor, the GMC hedge, and the sewed bridge. Okay, so here, as you can see, this is the RAM slots. Okay, here we have the RAM slots. So the kind of this RAM is the DDR3. Why DDR3? We have here DDR3, as you can see, 1.5 volt. This is 1.5 volt. So 1.5 volt is the working voltage for DDR3. So for DDR3, the working voltage is 1.5 volt. And the VTT, or the terminal voltage, is 0.75 volt. Okay, so this is DDR3. So this is the processor, the GMC hedge, the IC hedge. This is the RAM memory, as you can see. Here we have many circuits. Okay, so this is chemical capacitors. This is inductors. All those are inductors. Here we have MOSFETs. You can find MOSFETs in the shape with 8 pins, also in the shape. This is a small MOSFETs, and also those are MOSFETs. Here, this is the IC, power management IC. Here we have also another power management IC. Here, inductors. This is capacitors, as you can see. This is the network card. This is for the Wi-Fi. Okay, so as you can see here, as you can see, here we have the main power. Okay, this is the cable that is connected to the power jack, as you can see. And here, this is the charge IC that we're going to check. Okay, as you can see here. In the other side, as you can see, so in the other side we have the CMOS battery. As you can see, this is the CMOS battery. can see here to other side of the processor. Okay, this is a chemical capacitor. As you can see here, this is the super I/O. This is the super input output. Okay, I/O. Okay. Usually near to the super I/O we have this IC. This is the BIOS, the basic input output system. And of course here we have these connectors. Also you should check all these connectors. This is the power buttons. This is buttons. Okay. So now what should we do? We should first check these components using the multimeter. So let's put the multimeter to the continuity option and then press the power button. So now let's check this component. We will begin with, we check the power cable. Now we will check this inductors, as you can see. So let's check the continuity first. The continuity is set correctly. So now let's begin with the coils here. So as I told to you, the red wire should be connected directly to these coils, as you can see. Okay, so let's check these coils. This is a good coil. The second coil is good. Then 20 volt will pass through these coils and then goes to this MOSFET. So let's check this MOSFET. Will pass through these coils, as you can see, and then goes to the drain of this MOSFET. This is drain. Okay. So here we have drain. These 4 pins are connected together, as you can see, because this is drain. Here this is source. Why? Because we have this dot here. This point here means this is the first pin, this is the second pin, and this is the third pin. Always the 3 pins are for the source. Okay? Using this point, we can know that this is the first pin. So the first pin, the second, and the third always is the source in every MOSFET. And the 4th pin is for the drain. The drain contains 4 pins that is connected together, as you can see. All these pins are connected together. Okay. Also the source has 3 pins that is connected together. So now the 20 volt should pass through these coils and then goes to drain to all these 4 pins, and then should pass to the source. The gate here should receive the control signal from the IC. Okay, and then as you can see, the source of this MOSFET is connected, as you can see, of the source of this MOSFET. Here we have the point here, as you can see, means this is pin number 1, 2, 3. Okay, and the 4th pin is the gate, and here we have drain. The source of 2 MOSFETs are connected together. Okay, and here we have the drain. The drain also should be connected together. All pins here should be connected together, as you can see, because this is the drain. Okay, so 19 volt should pass through these 2 coils and then go to this MOSFET and pass through this MOSFET and then go to the second switch or second MOSFET and pass through it and then goes to this resistor. This is the current sense resistor. This is the current sense resistor. So let's check. The drain of this MOSFET should be connected to this resistor. So let's check, as you can see. And from this resistor, as you can see, the power will be distributed to the whole motherboard. Okay, the power will be distributed to the whole motherboard. So as you can see here, so for example, we have here many circuits. So here, if I check between this point and these circuits, I should find a continuity. Why? Because the 20 volt should pass directly from this directly to all these circuits. So let's check. So I will put 1 probe here, okay, in the current resistor, and then check here the MOSFETs here in this circuit. So for example, let's check the CPU circuit. Let's check. Always we should check the MOSFETs. Okay, as you can see, the see in the multimeter, low resistor. So the 20 volt pass directly from this resistor directly to this MOSFET, and then of course the 20 volt will be applied to this component in order to get the main power for the CPU. So let's check this also here, this circuit also. Always you should check the, as you can see, the MOSFETs, as you can see. Do you see? So this MOSFET here, this MOSFET, okay, receive 20 volt from this, and also the same for all circuits here. So let's check this circuit, for example. Here we have the 3 volt and 5 volt circuit, okay? So we have here the power management IC, we have here two MOSFETs, we have inductor, capacitor, as you can see, and inductors. So let's check. So here, as you can see, this is the current sense resistor here. So let's check. The 20 volt should pass directly to this circuit also. So let's check. So let's check this side also, as you can see. Okay. So this MOSFET, as you can see, is connected directly to this current sense resistor. So 20 volt will be distributed to the whole motherboard from this current sense resistor. Okay. So what should we have to do? I will connect the adapter directly to the power jack and then track to 20 volts in the motherboard until we find the problem. Okay, so let's get started. This is the adapter. Let's plug the adapter. So the adapter is plugged. So now let's put the multimeter to DC voltage. Okay, here we have 20. I will put it into 200. Always put the multimeter to the higher value. Okay, but first check the adapter whether we have the voltage in the adapter or not. So let's check the adapter. I will put the black probe here into negative terminal and then the red probe inside the adapter. So let's check in the multimeter. We have, as you can see, we have 20 volt, as you can see. That's why I put the multimeter to 200, because the adapter generates more than 20 volt, generate 20 volt or more, as you can see. If, for example, the adapter generates just 19 volt, I can put the multimeter to 20 volt. Okay. So once we check the serviceability of adapter, we find that the adapter is good. Now let's connect it to the motherboard. So now the adapter, as you can see, is connected to the motherboard. So let's check now the power. So first we should put the black probe to the ground here, for example, or anywhere in the motherboard. I will put it here in this ground, as you can see here. Okay, so let's check first these two wires. We should find 20 volt. So the first wire, as you can see, we have 20 volt. The second wire, we have 20 volt. Good. So let's go to the coils, these two coils. So the first coil, I have 20 volt here. Also the second, also 20 volt. 20 volt should be here also in the other side of coil. Here we have 20 volt. Here we have 20 volt. Good. So now this voltage will pass directly to the drain of this MOSFET. So let's check. As I told to you, these 4 pins are connected together. So let's check. The first pin, we have 20 volt. The second, 20 volt. The third, 20 volt. To add the last pin, 20 volt. Good. So now 20 volt should be passed directly to this side, but here, as you can see, we have the gate. The gate should receive the control signal. So let's check the control signal. Here we have the control signal, about 19. Okay, the control signal is generated by this IC, as you can see. Okay, so let's check now the source. Once we have the control signal, the source, we should get 19 volt or 20 volt in the source, as you can see. Okay, in all these pins we have 20 volt, as you can see. Okay, because this MOSFET is connected to this MOSFET, I mean the source of this MOSFET is connected to the source of this MOSFET, as we have seen before, we should of course find here 20 volt or 19 volt, 0.7 or 8. So let's check here the first pin of the source, as you can see 19 volt, 0.7 or 8 equal to 20 volt. The second pin, as you can see, the third pin. Okay, so now this 19 volt, 0.7 should pass to this side, but first the IC or the MOSFET should receive what? The control signal in this pin. This is the gate. So let's check the gate. We have 19 volt. So the MOSFET has received the control signal from this IC. So now we should find here the 19 volt, 0.7. So let's check the first pin. We have 0. Let's check the second. 0. The third. So here we have the problem. So let's check again the source. We have 19 volt, 0.7. Let's check the gate. We have the control signal. Here we should get here 19 volt, 0.7. Because we don't get here 19 volt, 0.7 means this MOSFET is failed. We should replace this MOSFET with a serviceable MOSFET. This is the problem for this motherboard, because here, as you can see, in the source we have the voltage, and also the gate receive the control signal from this IC, but we don't get here any voltage. Means this is the problem. We should replace this MOSFET. So let's go and replace this MOSFET. So as you can see, this is the failed MOSFET, as you can see. So this is the failed MOSFET. So here, this is inductors, as you can see. We get here voltage. Also we get voltage here in the drain of this MOSFET. Okay, here we have source, as you can see. We have this dot here, means this is the first pin. This is source. These three are source. Here we have gate. Okay, and for this MOSFET we get also voltage here, and we get the control signal, but the voltage doesn't pass to the drain, to this side. So this MOSFET is a bad MOSFET. We should replace it. So as you can see here, this is the reference for this MOSFET. We have here 4423. We should replace this MOSFET with another MOSFET with the same reference. So let's replace this with another MOSFET. So to remove this MOSFET, this bad MOSFET, and to replace it with another MOSFET, so I have here the good MOSFET, as you can see. So this is the good MOSFET with the same reference. Now I will remove this, the bad MOSFET or the failed MOSFET, as you can see, and I will replace it with this one. This is the good one. So to remove this MOSFET, we will need a tweezer. Okay, this, as you can see, and we will need, as you can see, the soldering paste. Okay, so as you can see, we will need the soldering paste. So we will just make a small amount of soldering paste over the MOSFETs, and then we will use the hot air. Okay, we will use the hot air to remove this MOSFET. So let's get started. So as you can see, I remove now the MOSFET, the bad MOSFET, as you can see here. So, and this is the good one, but pay attention, as you can see here. Do you see this mark? This white mark means the source. We we have here this dot here should be with this white mark here. So this is the source, okay, the first one. So let's put here some soldering paste, as you can see. So now we will place the MOSFET. So as you can see here we have this dot here should be next to this white mark. As you can see, this is the new MOSFET.